Hi everyone, today we are going to create a bubble chart in RStudio. A bubble chart is a type of data visualization that uses bubbles to represent three or more dimensions of data. It is a variation of scatter plot where each bubble's position represents two dimensions, one on x and one on y-axis, while the size and sometimes color and border of the bubbles encodes additional variables. So I've listed all the variables here so everyone can see which variable is used for which specific purpose in the bubble chart. First of all, we need to set the working directory, and for that, I am going to run this code. It gives me no error message, which means we successfully assigned RStudio_BP as a working directory. Next, we need to install packages and load libraries. We use ggplot2 for creating a high-quality customizable visualization. dplyr is used for data manipulation such as grouping, filtering, and summarizing, and foreign is used for reading external data formats like .xpt files used by enhanced dataset. As I've already installed these packages, so I'm just going to skip this step here and I'm just going to load these libraries all at once. After that, we are going to load enhanced 17 dataset into R. So I'm going to run this code and it ran successfully. Now we're going to create a new dataset which includes only those variables that we are going to use for the tutorial. I run this code and it gives me no error message, which means it ran successfully, and we can also see the enhance_clean dataset in the environment window. It includes only 5 variables that we are going to use in the creation of our bubble chart. After that, I'm going to check IND-FMPIR, which is ratio of family income to poverty, using summary command to identify its range and any potential outliers that need adjustment. So I'm just going to run this code, and it says 5 as max here in the console, so it needs no recording and is already cleaned up. Similarly, I inspect PAQ610 by running summary and table code, and it shows 99 as max here, which means that it needs some recording and we need to change refused or don't know 99 or 77 to N. For that, I'm going to run this code. And after that, I'm going to run this summary or table code to check the recoding. And now there's no 99 that appears here in the console, so it is perfectly recoded. We also inspect the variable re-agender. So I'm running the summary or table code once again. There's no refused or don't know values here, but it shows 1 and 2 instead of male and female. So we need to convert it to a factor variable. For that, I'm running this code, and after that, I'm checking the changes that I made with the summary and table code. So now you can see that male and female appears here in the console instead of 1 and 2. We can inspect the variable ever use marijuana or hashish in the same way. And it shows 9 as max, which means that, and it also shows 1 and 2 instead of yes and no. So which means that we need to convert it to effective variable, and we also need to change refused and don't know values to missing. For that, I'm going to run this code, and after that, I'm going to check the changes that I made. So now it says yes and no, and there's no 9 that appears here in the console after the recoding. So it's recoded perfectly. We inspect a total number of people in the family for invalid responses and ensure it is a numeric variable. When I run table or summary code, so it says 7 as max. So now we're just going to check this variable. So it includes 7 as 7 or more people in the family, and 7 doesn't mean refused or don't know values. So there's no need to change or convert any value here. It's already cleaned. After that, I'm going to filter out missing values because we don't want NAs to appear in our bubble chart. So for that purpose, I'm going to run this code and it ran successfully. Now, no missing value is going to appear in our bubble chart. After that, we are going to create a basic bubble plot with ratio of family income to poverty on the x-axis and number of days vigorous work on the y-axis. So the scatter plot, it looks on the right side of the screen. At this point, this bubble plot looks just like a scatter plot, but I assure you that it will get better with further coding. We can add bubble sizes on the bubble plot using total number of people in the family. And when I run this command, you can see that it appears here. After that, I'm adding color aesthetic reagender to differentiate bubbles based on gender. When I run this command, oops, sorry. So when I run this command, you can see that reagender also appears here. So now males and females have different colors. You can see the bubbles with two different colors, one for males and one for females. After that, we are adding bubble borders to the bubbles based on variable ever used marijuana and hashish. So this shape is equals to 21. It gives a point shape that supports both interior color and border color, and stroke is equals to 1 sets the border thickness for the bubbles. Now we can also customize bubble sizes based on total number of people in the family and add legend labels. So I'm just going to run this code real quick and then tell you more about it. So scale size containers customizes the size range for bubbles to make them visually distinct. Here bubble sizes range from 3 to 11. We also added a meaningful legend label for DM, DF, MS, IZ here. Similarly, we can customize the interior color of the bubbles based on reagender. I'm going to run this code and then explain you about it. So we use a scale fill manual here to assign specific colors for gender. We are using yellow bubbles for male and pink bubbles for female. We can also customize color for bubble borders based on ever used marijuana or hashish. So I'm going to run this code first. Okay. So we use scale color manual to assign custom colors for the bubble borders on the basis of if they have ever used marijuana or hashish. We are using blue color for yes and red color for no, as you can also see in the bubble plot. We also added a meaningful legend label for DUQ 200 that you can see here. Now I'm applying theme minimal for our bubble plot. I'm just going to run this code. Okay. So applying theme minimal for a bubble plot ensures that the plot has a clean, simple aesthetic without gray background or distracting elements. And now you can no longer see the gray background in the bubble chart. And it also enhances the readability for the audience. After that, we can save the base plot as bubble plot B. So we don't have to rewrite the entire plot code if we want to make changes or add details. So I'm just gonna do that and save the bubble plot as bubble plot B. And you can also see the bubble plot B in the environment window. After that, we can add titles and can play with other aesthetics of the bubble chart. I run this code quickly and then talk you through it. So we use labs to add titles in the bubble plot B. We use title, which sets the main title of the bubble plot. Subtitles add a subtitle explaining the visualization details such as bubble size, bubble border, and bubble color. And X labels the x-axis, Y labels the y-axis. Fill adds a legend title for bubble fill gender, and we also added a caption at the bottom of the bubble plot. So in the next code, we center the main title, subtitle, and captions in the bubble plot B. Okay. So plot caption targets the caption text at the bottom of the plot, and h just is equals to 0.5 horizontally centers the caption text. Plot dot title centers the main title of the bubble plot, and plot dot subtitle centers the subtitle for better alignment with the main text. When I run this code, now you can see the difference in the bubble plot before and after running this code. In the next code, we can change the main title color and font size. We can do this to enhance the appearance. We can also play with other aesthetics of the bubble chart, but at this time, I just want to add a blue color to the title of the bubble chart, and also I want to make it look a little bigger in size. So I'm just going to run this code, and now you can see that the main title, it appears in brown color and also a little bigger than it was before. In the next step, we add facet traps. So overall, our bubble plot looks good here, but it is little cluttered. And to deal with that issue, we can add facet trap. So I'm just going to run this code, and there's no error message. Okay. So here facet trap is helpful because it lets us compare how the relationship between income to poverty ratio and number of days vigorous work varies based on whether someone has ever used marijuana or hashish. If we plot everything together without facets that we did in this code, the points from the yes and no groups for DUQ 200 would overlap, and which makes it a little harder to distinguish patterns specific to each group. So overall, in this graph on x-axis, we have continuous variable income to poverty ratio, and higher values indicate families with more income relative to poverty line, and lower values indicate those closer to or below the poverty line. Y-axis represents the number of days individuals engaged in vigorous work activities, that is physically demanding labor or exercise. This shows how physical activity correlates with economic status. The size of each bubble corresponds to the total family size. Larger bubbles indicates larger households, like the bubble that you can see here, and while smaller bubbles indicate smaller households, like this bubble and even this one here. This adds another dimension showing how household size interacts with income and physical activity. The interior bubble color encodes gender. Yellow represents male, while pink represents female. This helps differentiate trends or distributions based on gender in the bubble plot. The bubble border, DUQ 200, indicates whether the individual has ever used marijuana or hashish. Those who ever used marijuana or hashish are plotted on the left side of the bubble chart, and those who never used marijuana or hashish are plotted on the right side of the bubble chart. This highlights potential relationship between lifestyle behaviors and economic physical activity variables. So this is it. If you have any questions, please let me know. Thank you.